Hello, my name is Rich Howard, owner of Architectural Builders Supply, and this video is to bring you a closer look at the C.R. Lawrence. This is their part number JC6085844. This is what they call a heavy-duty spring hinge with a 5/8 radius. The hinge that we're looking at here is in the satin brass finish, and this hinge is available in two finishes. It is, and I'm pulling that up now, forgive me. It is also available in a black finish as well. So you can get it in satin brass or black. This is a 4x4 spring hinge, and let's just take a tour of this hinge. The height is the first dimension on hinges like this, and that's, well, maybe not important for this hinge or your application. It's important to know that the height is the first dimension, because there are rectangular shaped hinges where that matters. 4x4. This has a 5/8 radius, which is very common, and that's achieved when the door manufacturer is using an 1¼ inch diameter bit and routing out the door and the frame and not going back to square the corners of that preparation. And the reason that they do so is just time, efficiency, manufacture more doors per hour sort of scenario. The location of the holes for these screws is what is considered template pattern. The word template is used to mean that the location of these screws comply with a very specific set of locations. And I'm going to hold the tape measure up to the hinge so that you can study where that all falls. You can obviously pause this video should you need. Flip that over and bend it back and get an idea of where they fall in terms of the edge of the hinge as well. The point of me revealing this to you or showing it to you is that I don't want you to buy the hinge not knowing if it will fit if you are changing an existing hinge to a new hinge. The reason is that there are several and many patterns of where the holes are located. This is called template. Half moon, some people call it. It's very, very, very common, but it is by far not the only one that exists. So pause the video prior and study those locations. If you need a hinge that does not meet those hole locations, reach out to us. We'll be happy to assist you with that. There are photographs, I should say, down below this video that will allow you to study the hinge in detail. Holding that up there so you can view it. And this is going to include screws and a complementary finish. Every order will give you at least one tension rod. This is an Allen key, really. And then one tension pin. You need a tension pin for every hinge, because how these work is that when the hinge is installed and the tension collar, which is up here, you can see that there is not a location for the Allen wrench here, but there is here. That'll be called the tension collar. There's the hole there for access of inserting in your tension pin. And when you insert the tension rod into the top of the hinge or the tension collar and you turn it clockwise, you reveal new additional holes as a result of doing that. And it's into one of those new holes that you're going to insert that tension pin, allowing you to set and retain tension really on the internal spring that's there. This would be a 4x4 hinge, would be quite appropriate for an 1¾ inch thick door. Too big for an 1 3/8 door. You'd want a 3½ inch version for that size. And you can also do a 4½ inch spring hinge as well from C.R. Lawrence. Where are you going to use this? Well, residential applications. You might have a attached garage door where the door is per code fire rated. You might have one on the front door. You might have these installed in an office setting where you simply want a door to close all the time, and you're going to use a spring hinge by which to accomplish this. It is best to install spring hinges not at the top of the door, but at the middle or the bottom. The top hinge location is that hinge that actually does the job of holding the majority of weight of the door. And spring hinges are not technically load rated at all, so you don't want the spring hinge doing the work of not only trying to close the door, but also trying to hang the door. 70% of that door weight's on that top hinge. Put your good ball bearing hinge there, and a commercial grade hinge is going to work well with this. What they don't give is the thickness of the leaf, and you're going to want to make sure that the other hinges that you have are compatible with this leaf thickness. The caliper tells us that it's 0.103 inch. That's an unusual size. So you're going to want to go with what would be classified as a residential leaf hinge, because a 4x4 commercial grade, and they call this heavy duty. They're not using the term heavy duty appropriately, in my opinion. This would be called residential duty. You're going to want a leaf that is going to be compatible with that, or very close to 100 thousandths. Ball bearing would be great for that top hinge or the other locations, because a commercial grade 4x4 hinge would be 130 thousandths. And as that leaf thickness changes, you don't want to have the mechanics of the hinge as the door opens become something that's incompatible. So make sure that your leaf thickness is compatible across all the hinges hanging the door. So put this at the middle or bottom. You should probably have two, would be my guess. One would be only if you had an incredibly light door, like a hollow core door. But generally, you're going to see two hinges on a solid core door. And, you know, I'm a fan of all spring hinges in the sense of if you have a door that you really need to try to be able to get it closed, but two ought to be quite adequate for doors. And this hinge is rated for doors up to 2'8" wide. For 4 inch, 3 foot wide, and 7 foot tall would be the maximum size for this. There's a link below this video to the installation instructions that will give you an overview of all of those aspects. The important part is it says do not exceed 3 holes of tension for doors opening to 180 degree. No more than 3 holes set, or 4 holes if you can actually achieve 180 degree opening with your door, and you're going to, don't go more than 3 holes worth of tension, because as you open the door it sets additional tension. If your door is going to get to 90, you can go up to 4 holes of tension. And spring hinges are nice because you can adjust them as the seasons change, as the ambient air pressure in a building changes. Think of a 3-flat building where in the summertime windows are open in the back of the building, let's say, and as the door is opened and then closed, you've got more air coming through than you would in a winter time application, so you can adjust that spring hinge. Now, I'm not a fan of spring hinges because I don't believe they're the elegant way to close a door, because you don't really have control over spring hinges, except that you can set the spring and then let it fly. Whereas a good way to, the proper way to control a door would be hydraulically, like an overhead surface closer, a floor closer, an overhead concealed closer. However, there are instances when that's simply not permissible, whether it be compatibility, the ability to install it economically. Maybe it's just easiest and the most direct path forward to use a spring hinge. So they're great in that sort of regard, but don't consider them the primary means by which to have a door reliably close all the time. That should be controlled with something more appropriate for it. Setting the tension, is something you're going to test. Set that tension accordingly to make sure that the door not only closes but latches. And that's the key when you have a fire-rated door. The door is not technically fire-rated unless the door is both self-closing, but it must be self-latching. When you get into hydraulic control over a door, you can generally control the sweep degree of closing of the door, but also the latch, the last 10 degrees or so. A spring hinge doesn't allow that naturally. So you're going to want to have, I would like to have 2 hinges on a door, 2 spring hinges on a door, so that you can have more stored energy as the door is opened. That ought to allow you the ability to get the door to close without having it slam shut, with enough residual stored energy in the springs to get it to latch properly. I liken stored energy in the spring to a tugboat. They don't go very fast, but they can pull a lot of weight. And having more spring hinges, 2, let's say, rather than 1, would be advantageous to having residual stored energy left at the crucial last 10 degrees of opening, okay, or I should say of closing. Very simple, straightforward. The name C.R. Lawrence, quite synonymous with many things hardware related, not only for regular doors, but for aluminum storefront doors, for all glass doors. There's a link below this video to the manufacturer's page where you can pull up not only all the C.R. Lawrence products that we sell, but a link to the manufacturer's website, as well as a link to the full product catalog. If you have any questions on the C.R. Lawrence, this is their part number JC6085844, 4-inch by 4-inch 5/8 radius satin brass spring hinge, or any other C.R. Lawrence product. Please feel free to reach out to us. And thank you.